Picture this, the vast, infinite expanse of space stretching out endlessly, filled with billions of galaxies, countless stars, and worlds we can only dream of. Yet, amidst this stunning beauty lies a darker, more enigmatic side, an endless vault of mysteries that defy all logic and understanding. What if I told you that some of the most brilliant minds on Earth have stumbled upon cosmic riddles so perplexing, so unexplainable, that even our most advanced technology cannot crack them? From signals that whisper across light years to celestial objects behaving in ways we never imagined possible, the universe is teeming with anomalies that challenge everything we think we know. And these aren't just theoretical puzzles, they hold the potential to rewrite the very rules of science. So, join us as we dive deep into the top 10 unexplained space anomalies that continue to baffle scientists and ignite our curiosity. By the end of this journey, you might just find yourself questioning how much we truly know about the cosmos, or if it's the universe itself that's keeping its secrets deliberately locked away. Now turning to one of the most iconic and mysterious signals ever captured from the cosmos, let us dive into the story of the WOW signal. In the summer of 1977, while analyzing data collected by a giant radio telescope in Ohio, astronomer Jerry Amon stumbled across something extraordinary, a strong, narrowband radio signal lasting for 72 seconds. Its intensity and precision stood out so much that Jerry, in sheer astonishment, circled the printout and scribbled the word "wow" in the margin, giving this anomaly its unforgettable name. But what made this signal so special? It came from the direction of the Sagittarius constellation, yet no known celestial object or human-made satellite could explain its origin. The signal's frequency was remarkably close to a sweet spot in the radio spectrum where interstellar communication could theoretically occur, often referred to as the water hole by scientists. This added fuel to the tantalizing possibility that the WOW signal might have originated from an extraterrestrial source. Decades of searching have followed, with teams scanning the same part of the sky hoping for a repeat transmission, but the cosmos has stayed eerily silent. Researchers from the Search for Extraterrestrial Intelligence, or SETI, continue to debate whether this was a fleeting message from another civilization or simply an unexplained natural phenomenon. To this day, the WOW signal remains an enigma, a brief whisper from the depths of space that left us with more questions than answers, challenging us to rethink what might just be out there, waiting to be discovered. And as we ponder this cosmic mystery, it raises yet another question. Could this signal be a one-time anomaly, or will the universe someday reveal more clues to unravel its deepest secrets? Moving forward, let us delve into the possible explanations for the WOW signal, a mystery that has, for decades, left scientists both fascinated and perplexed. One suggestion is that the signal could have originated from a distant star system, perhaps carrying the faint echoes of celestial activity. However, no stars or known celestial objects in the vicinity of the Sagittarius constellation have been able to account for the unusual intensity and narrow frequency of this signal. Another theory points to comets, specifically two comets that were in the area during the detection of the signal. These comets emitted hydrogen clouds, which could, in theory, produce a spike in the same frequency range as the WOW signal. Yet, when later observations were conducted under similar conditions, no matching signal was detected, leaving this explanation incomplete. Then, of course, there is the most captivating possibility of all extraterrestrial intelligence. The WOW signal's characteristics align with what scientists might expect from a deliberate interstellar message, such as its precise frequency in the so-called water hole, a region considered ideal for communication due to its lack of cosmic noise. But even this thrilling hypothesis faces challenges. Why was the signal a one-time event? Why haven't we detected anything similar since? Could it have been a fleeting attempt to reach out, Or were we simply in the right place at the right time to catch a glimpse of an alien civilization's existence? Perhaps the answer lies in something we have yet to discover, a natural phenomenon entirely unknown to current science, or a technological source beyond our comprehension. Each hypothesis, whether grounded in astrophysics or tinged with the allure of the unknown, only seems to deepen the enigma. The wow signal remains a puzzle piece that doesn't quite fit into the cosmic puzzle we're trying to solve, fueling debates and inspiring new generations of astronomers and thinkers to look deeper into the heavens, wondering if we might one day hear another faint call from the cosmos. Now turning to another cosmic enigma, let us explore the perplexing phenomenon surrounding Tabby's star, also known by its less memorable designation KIC 8462852. This star, situated around 1,400 light-years away in the Cygnus constellation, has baffled astronomers since its irregular light patterns were first observed in 2015. Unlike the predictable dimming seen in most stars caused by orbiting planets, Tabby's star exhibits a chaotic and highly unusual pattern of brightness dips, with its light sometimes dimming by as much as 20%, a scale far too large to be caused by a planet. This erratic behavior has sparked numerous theories, ranging from the mundane to the extraordinary. On one hand, some scientists suggest that the dimming could be due to massive clouds of dust or fragments from asteroid collisions partially blocking the light. However, these explanations are not without their challenges, as the material required to produce such significant dimming would have to be unusually dense and persist over long periods. On the other hand, there's the far more speculative and undeniably intriguing idea that the dimming of Tabby's star might be caused by an advanced alien civilization. In this scenario, the irregular light fluctuations could be attributed to a massive structure, something akin to a Dyson sphere, potentially built to harness the star's energy. While this possibility has captured the public imagination and driven countless discussions, it remains purely hypothetical, especially as follow-up observations have failed to uncover any concrete signs of artificial activity, such as radio signals or detectable emissions often associated with advanced technology. The scientific community remains divided, with some emphasizing the need for more data and improved modeling, while others consider the star's behavior to be an entirely natural phenomenon yet to be fully understood. As we continue to observe Tabby's star with more advanced tools and telescopes, the mystery persists, serving as a humbling reminder of how much we still have to learn about the wonders of the universe and the countless surprises it holds. As the next challenge unfolds, let us delve deeper into the unsolved mysteries surrounding Tabby's star. Despite years of observation and data analysis, astronomers remain at a crossroads when it comes to pinpointing the exact cause of its extraordinary dimming patterns. One major hurdle lies in the immense distance separating us from this star, around 1,400 light-years. This vast expanse complicates our efforts to gather detailed, high-resolution data, as even our most advanced telescopes struggle to reveal the finer intricacies of such a distant stellar system. Furthermore, the unpredictable nature of the dimming itself adds to the challenge, as astronomers cannot reliably predict when and how the star's brightness will fluctuate, making it difficult to coordinate observation periods and collect consistent data. Beyond these technological limitations, the implications of discovering an advanced alien civilization, should the speculative Dyson sphere theory ever be proven, are profound. It would not only reshape our understanding of life in the universe, but also raise staggering questions about the technological capabilities required to construct such a megastructure and the intentions of its creators. Yet, the absence of evidence does not necessarily equate to the absence of possibility. Astronomers are continuing to explore new methods of observation and analysis, such as studying the star's light spectrum in greater detail or conducting long-term monitoring to identify any patterns previously missed. Meanwhile, alternative explanations still warrant deeper exploration. Could there be a yet unidentified natural phenomenon at play, one that challenges the limits of current astrophysical models? Or is it possible that the answers lie in a combination of factors too complex or subtle to isolate with present-day tools? Whatever the case, Tabby's star stands as a compelling mystery, one that bridges the boundaries between science fact and science fiction, and it serves as a testament to the ever-evolving nature of our quest for knowledge. Moving forward, let us turn our attention to the next cosmic enigma, one that pulls not just our curiosity but also entire galaxies, an anomaly known as the Great Attractor. As the next challenge unfolds, let us explore the perplexing anomaly known as the Great Attractor, a gravitational force so immense that it draws millions of galaxies, including our very own Milky Way, toward its enigmatic core. This colossal phenomenon lies at the heart of the Laniakea supercluster, a massive collection of galaxies bound together by gravity. However, what makes the Great Attractor truly baffling is its location hidden behind a region of the sky called the Zone of Avoidance. This area is densely packed with stars and cosmic dust from our own galaxy, effectively obscuring direct observations of this cosmic mystery. Imagine trying to peer through a dense, foggy window to glimpse a world-shaking event. That is the challenge astronomers face when studying the Great Attractor. Its immense gravitational pull suggests the presence of an extraordinary mass, possibly a supercluster of galaxies or something even more mysterious, such as an enormous concentration of dark matter. Yet, its exact nature remains elusive, as does the question of whether this force represents something entirely unknown to modern astrophysics. Current studies rely on indirect methods to map its influence, such as tracking the motion of galaxies affected by its gravity and analyzing X-ray emissions from hot gases within surrounding clusters. But what could generate such an overwhelming force in this veiled corner of the universe? Could it reveal hidden truths about the large-scale structure of the cosmos? Or might it point to a phenomenon that defies our current understanding of space and gravity? As researchers continue to develop more advanced tools and techniques to penetrate the veil of the Zone of Avoidance, the Great Attractor remains a tantalizing riddle, one that pulls on both our instruments and our imaginations. With these mysteries in mind, let us journey onward to uncover the theories and challenges that make this anomaly one of the most enthralling enigmas in our exploration of space. Moving forward, let us delve deeper into the theories surrounding the Great Attractor and the significant challenges that its study presents. One prominent hypothesis suggests that the Great Attractor is a massive supercluster of galaxies, an immense gravitational powerhouse capable of pulling millions of galaxies toward it. This idea aligns with the known patterns of galaxy distribution in the universe, where galaxies tend to form clusters and superclusters interconnected by cosmic filaments. However, the scale and intensity of the Great Attractor's pull hint at the possibility of an even more exotic explanation. Some scientists speculate that this gravitational anomaly might be linked to an enormous concentration of dark matter, the mysterious and invisible substance believed to make up most of the universe's mass. Dark matter does not emit, absorb, or reflect light, which makes it impossible to observe directly, but its gravitational effects are undeniable. If dark matter is indeed involved, it could provide a crucial piece to the cosmic puzzle of how matter is distributed on a grand scale. Yet, the Great Attractor's location complicates its study significantly. Sitting behind the Zone of Avoidance, an area heavily obscured by our galaxy's thick clouds of stars, gas, and dust, it remains shrouded in mystery. Traditional optical telescopes struggle to penetrate this dense region, forcing astronomers to rely on alternative observational methods. For example, powerful radio and infrared telescopes can detect signals that pierce through the interstellar dust, offering indirect glimpses of what lies beyond. X-ray observations are another tool, as they can reveal high-energy emissions from the hot gases within galaxy clusters surrounding the Great Attractor. Despite these efforts, the true nature of this colossal force continues to evade a definitive explanation. Moreover, the challenge of studying such a distant and heavily obscured phenomenon highlights the limitations of our current technology. Advancements in observational tools such as next-generation space telescopes and more sensitive detectors promise to extend our reach into these hidden regions of the universe. For now, the Great Attractor stands as a testament to how much we have yet to learn about the cosmos, embodying both the complexity and wonder of space exploration. As we continue to push the boundaries of our understanding, this gravitational enigma remains a central figure in the story of our universe, inviting us to reconcile its mysteries with the broader framework of astrophysics. Now turning to the perplexing Pioneer Anomaly, we encounter one of the most intriguing mysteries in the history of space exploration. The Pioneer 10 and Pioneer 11 spacecraft, launched in the early 1970s, were humanity's first robotic emissaries to venture beyond the outer planets. These spacecraft provided groundbreaking data about the outer solar system, but their journeys into the vastness of interstellar space revealed something unexpected, a subtle but persistent deviation in their trajectories. As they moved further away from the Sun, both spacecraft experienced an unexplained acceleration directed toward our solar system. This anomaly defied the predicted paths calculated using the well-established laws of physics, leaving scientists baffled. Early hypotheses to explain this strange behavior explored a wide range of possibilities, from gravitational influences of unseen celestial objects to interactions with the interstellar medium. Some even speculated that the anomaly could point to a flaw in our understanding of gravity itself, hinting at the need for new physics. However, more recent investigations turned the spotlight on the spacecraft themselves. Careful analysis revealed that heat emitted by the spacecraft's power sources and systems might be generating a minute but measurable recoil force, which could account for the observed acceleration. While this explanation has largely been accepted, it does not erase all questions. The Pioneer Anomaly serves as a valuable reminder of the complexity of space exploration and the importance of scrutinizing every factor, no matter how small, that might affect our interpretations. This enigmatic deviation not only challenged our understanding of the universe, but also underscored the precision required for deep space missions, cementing its place as a fascinating chapter in the story of humanity's journey into the cosmos. With the next phase of the journey in sight, let us delve deeper into the final thoughts surrounding the Pioneer Anomaly. While the explanation pointing to heat emissions as the source of the anomaly has gained significant support, it is worth noting that it is not without lingering uncertainties. For instance, the precision required to fully account for the deviation still leaves room for doubt, as some measurements suggest gaps that are yet to be completely reconciled. These uncertainties fuel ongoing discussions about whether additional factors, perhaps unknown influences in deep space, could be at play. Beyond the specifics of the Pioneer Anomaly itself, this case has broader implications for our understanding of spacecraft propulsion in the vast emptiness of interstellar space. It highlights how even-minute forces, like the thermal recoil effect, can significantly alter the behavior of spacecraft over immense distances. Such insights are crucial as humanity prepares for more ambitious deep space missions, where a complete understanding of propulsion dynamics will be imperative for navigation and success. The Pioneer Anomaly also serves as a humbling reminder that space exploration is a constant dialogue between discovery and refinement. Even as one mystery appears to be solved, new questions arise, ensuring that our quest to understand the cosmos remains as challenging as it is inspiring. As we look back on this anomaly, it not only underscores the importance of rigorous scientific analysis, but also exemplifies the boundless curiosity that drives us to explore beyond the known, forever reaching for the stars. Now turning to the mysterious phenomenon of fast radio bursts, these fleeting yet immensely powerful bursts of radio waves have captured the fascination of astronomers worldwide. First discovered in 2007, fast radio bursts, often abbreviated as fast radio bursts, are extremely short-lived events, typically lasting just a few milliseconds. Despite their brevity, the energy they release in that fraction of a second rivals the amount of energy our Sun emits over several days. These bursts originate from distant galaxies, spanning billions of light years, making their detection an incredible feat of modern astronomy. What truly adds to their enigmatic nature is their unpredictability. While most fast radio bursts are one-off events, scientists have identified a few that repeat over time, raising even more questions about their origin. Could these recurring bursts be tied to specific cosmic phenomena, or do they point to processes we have yet to understand? Theories about their cause range from cataclysmic events like neutron star collisions or black holes devouring matter, to more exotic ideas such as advanced alien civilizations intentionally sending signals across the cosmos. The variety of explanations speaks to the sheer mystery of these bursts, as none of the proposed theories fully explain all the observed characteristics. Adding to the intrigue, the immense distances these radio waves travel suggest they could provide valuable insights into the properties of intergalactic space itself. By studying fast radio bursts, scientists hope to decode messages from the universe's most extreme environments, unlocking secrets about star formation, galactic evolution, and perhaps even more profound cosmic questions. Yet, for now, fast radio bursts remain one of the most tantalizing puzzles in modern astrophysics, a reminder of how much more there is to uncover in the great expanse of space. With the next phase of the journey in sight, let us delve deeper into the hunt for the source of these enigmatic fast radio bursts. Scientists across the globe have dedicated advanced telescopes and cutting-edge technologies to track down the origins of these mysterious signals. Observatories such as the Canadian Hydrogen Intensity Mapping Experiment, located in British Columbia, and the Milky Way Radio Telescope in South Africa are pushing the boundaries of astrophysics in this quest. One promising avenue of exploration focuses on pinpointing the precise locations of fast radio bursts within their host galaxies. By analyzing the environments where these bursts originate, researchers aim to uncover clues about the astronomical events or conditions that might produce such powerful phenomena. Some fast radio bursts have been traced back to regions densely packed with young stars, which suggests that highly energetic remnants like magnetars could be responsible. Magnetars, which are a type of neutron star with an extraordinarily intense magnetic field, have emerged as one of the leading natural explanations. Their extreme magnetism and rapid rotations might generate the right conditions for these bursts. However, the discovery of repeating fast radio bursts complicates the picture, as it implies some sources are capable of emitting multiple signals over time, which does not align with many catastrophic one-time events like neutron star collisions. On the more speculative side, theories involving alien civilizations have also gained traction, fueled by the idea that these bursts could be intended as signals or even propulsion methods for advanced extraterrestrial technologies. While these ideas are far from proven, the mere possibility keeps the scientific debate lively and pushes researchers to keep an open mind. Beyond the mystery of their origins, fast radio bursts hold the potential to unveil hidden details about the universe itself. As these signals travel through vast cosmic distances, they interact with the electrons and magnetic fields in intergalactic space, effectively carrying a record of the regions they pass through. By studying the distortions and delays in these signals, scientists gain unique insights into the invisible structures of the cosmos, enriching our understanding of the universe's large-scale composition. The pursuit of answers about fast radio bursts represents not just a search for their immediate cause, but also an opportunity to decode a broader cosmic narrative, one that underscores the limitless possibilities waiting to be discovered. Moving forward, let us explore the fascinating story of Oumuamua, the very first known interstellar object to pass through our solar system. Discovered in 2017 by astronomers using the Panoramic Survey Telescope and Rapid Response System in Hawaii, Oumuamua immediately captured the world's attention. Its name, which means scout or messenger in Hawaiian, perfectly reflects the mysterious nature of this visitor from beyond our solar system. What truly sets Oumuamua apart is its peculiar characteristics. Unlike any asteroid or comet we have observed before, this object has an elongated, cigar-like shape estimated to be hundreds of meters in length, yet its width is only a fraction of that. This unusual structure contradicts the standard circular or irregular shapes seen in most celestial bodies. Adding to the intrigue is its unexpected acceleration as it traveled away from the Sun. Normally, objects like comets experience acceleration due to the outgassing of volatile materials when heated by the Sun. However, Oumuamua displayed no visible signs of outgassing, no detectable tail, and no dust cloud trailing behind it, leaving scientists puzzled. These anomalies have sparked heated debates among researchers about its true nature. Some hypothesize that it could be a peculiar type of comet or asteroid from a distant star system, shaped over eons by gravitational forces and collisions. Others, however, consider more unconventional possibilities, including the tantalizing idea that it might be an artifact of alien technology. This theory gained traction when Avi Loeb, a renowned astrophysicist, suggested that Oumuamua's unique shape and unexplained acceleration could point to it being a solar sail, a type of spacecraft that harnesses the power of starlight for propulsion. Though speculative, such ideas challenge our understanding of what might exist in the vastness of space and keep the dialogue surrounding extraterrestrial possibilities alive. Despite its fleeting visit, Oumuamua has left an indelible mark on our quest to uncover the mysteries of the cosmos. Its brief appearance has spurred a new era of interstellar object tracking, encouraging scientists to develop more advanced systems to monitor and study potential future visitors. Whether a natural oddity or something far more extraordinary, Oumuamua reminds us of how much there is to unravel about the universe, compelling us to look deeper and prepare for the unexpected. With the next phase of the journey in sight, let us dive deeper into the controversial theory proposed by Avi Loeb and his colleagues regarding Oumuamua's potential alien origins. The idea that this object could be a piece of alien technology stems largely from its baffling features. Loeb highlights that Oumuamua's peculiar elongated shape and lack of visible outgassing are not typical of natural celestial bodies like comets or asteroids. Its unexplained acceleration away from the Sun further fuels this argument. Loeb theorizes that this behavior could be consistent with a solar sail, a thin, highly reflective structure capable of propelling a spacecraft using radiation from stars. Such technology is within the realm of human imagination, as similar concepts have been explored in our own scientific advancements. However, this proposal has sparked significant debate within the scientific community. Critics argue that while Oumuamua's characteristics are indeed unusual, extraordinary claims require extraordinary evidence. Many researchers point to natural explanations, such as a fragment of an interstellar comet shaped by tidal forces or a dense hydrogen iceberg that could accelerate without leaving a detectable trail. The lack of concrete evidence to definitively classify Oumuamua as a product of alien technology weakens this claim, leading many to lean toward more conventional hypotheses. Nonetheless, the cultural impact of the alien origin theory has been profound. It has sparked widespread public fascination and reignited discussions about extraterrestrial life. Popular media, books, and online forums have embraced the mystery of Oumuamua as a symbol of the unknown, inspiring both curiosity and speculation. This debate also underscores the importance of remaining open to all possibilities while maintaining scientific rigor. Whether or not Oumuamua turns out to be an artifact of intelligent life, Its journey through our solar system challenges us to expand the boundaries of what we consider plausible. It serves as a reminder that science thrives on curiosity and the willingness to explore even the most unlikely of scenarios. With each debate and discovery, we take a step closer to understanding our place in the universe and what other marvels might await us in the vastness of space. As the next challenge unfolds, let us explore the enigmatic phenomenon known as dark flow, a cosmic anomaly that challenges our very understanding of the universe. Discovered through extensive observations of galaxy clusters, scientists noted something extraordinary. These clusters appeared to be moving in the same direction at incredible speeds, as if drawn by some unseen force. This peculiar motion defies the expectations set by the standard model of cosmic expansion, which predicts a more random distribution of movement on such massive scales. The term dark flow was coined to describe this mysterious drift, and it has since sparked some of the most fascinating debates in astrophysics. One compelling theory suggests that this movement could be influenced by a colossal, unobservable structure lying beyond the edge of the observable universe. This structure, if it exists, could exert an immense gravitational pull strong enough to cause galaxies to shift in unison. Another, more speculative idea proposes the existence of alternate universes realms that might interact with our own in ways that produce these baffling effects. Some scientists argue that dark flow could hint at a multiverse, where our universe is merely one bubble among countless others, each with its own unique properties. Yet, like many space mysteries, definitive answers remain elusive. The vast distances and the limitations of current technology make it challenging to investigate the regions potentially responsible for this phenomenon. What we do know is that dark flow continues to defy conventional explanations, urging astronomers to refine their models and contemplate possibilities that stretch the boundaries of our imagination. While the true nature of dark flow remains unknown, it serves as a humbling reminder of how much we have yet to uncover about the cosmos. With this anomaly in mind, it is only natural to wonder, could these unexplained movements point to forces or entities we cannot yet grasp, or are they simply an intricate part of a universe we are only beginning to understand? With these profound questions lingering, let us now move forward to another theory-provoking concept that may push our understanding of reality even further. Now turning to the deeper implications of dark flow, let us explore the extraordinary possibility that it could be influenced by forces originating from beyond our observable universe. Imagine a gravitational pull so immense, so unfathomable, that it affects entire galaxy clusters, drawing them in a unified direction. If such a force exists, what lies beyond the observable limits of our universe? Some scientists hypothesize that this pull could be caused by structures or entities hidden in a region of space we simply cannot see, a realm that lies outside the boundary of light we are capable of detecting. This edge, often called the cosmic horizon, conceals what could be vast structures, such as undiscovered superclusters or even phenomena tied to dark matter. However, the most tantalizing theory goes even further. It suggests that the source of dark flow may not exist in our universe at all, but rather in another universe altogether. This brings us to the concept of the multiverse, a theory proposing that our universe might be just one among countless others, each with different physical laws, dimensions, and compositions. In this view, dark flow could be the result of gravitational forces exerted by a neighboring universe, interacting with ours in a way we have yet to comprehend. The idea of alternate universes interacting with our own is deeply captivating, but also incredibly challenging to prove. The biggest hurdle lies in the very nature of our observable universe. Since we are confined to only observing what light has had time to reach us, any evidence of forces from beyond this boundary remains indirect and speculative. Moreover, the tools and technology we currently possess are not advanced enough to test such grand ideas thoroughly. To truly validate the multiverse theory as an explanation for dark flow, we would need innovations far beyond what exists today, be it advanced telescopes, new ways to measure cosmic phenomena, or entirely novel approaches to understanding gravity itself. Until then, these theories remain on the frontier of astrophysics, sparking both excitement and frustration. Still, the possibility that our universe might be drifting under the influence of another reality is too intriguing to ignore. It poses questions that push the very limits of our understanding of space, time, and existence. Could dark flow be the first clue pointing us toward evidence of a multiverse? Or does this anomaly hint at forces we have not yet imagined within our own universe? The answers, if ever uncovered, could reshape our perception of reality in ways we cannot yet fathom. With these thoughts in mind, let us now move toward another cosmic mystery, equally baffling yet profoundly relevant to the search for life beyond Earth. Now turning to the mysterious detection of methane gas on Mars, this anomaly has captured the imagination of scientists and dreamers alike. Methane, a simple molecule consisting of carbon and hydrogen, might seem unremarkable at first glance. However, its presence on Mars is anything but ordinary. On Earth, methane is often produced by living organisms such as bacteria or through geologic processes like volcanic activity. The discovery of methane on Mars raised the tantalizing possibility that it could be a marker of microbial life existing beneath the planet's surface. In 2003, scientists detected significant methane spikes in the Martian atmosphere using Earth-based telescopes, a finding that was later supported by observations from spacecraft like the Mars Express orbiter. These methane emissions were not consistent but instead appeared as temporary spikes, with the gas mysteriously vanishing shortly after. The sudden detection, followed by its disappearance, left researchers puzzled and questioning what could be causing such fluctuations. One theory suggests that the methane could originate from subsurface reservoirs, trapped under Martian soil for millions of years, occasionally releasing bursts into the atmosphere through cracks or seasonal changes. Alternatively, the methane could be the result of non-biological processes such as serpentinization, where chemical reactions between rock and water produce this gas. While both explanations are plausible, neither fully accounts for the erratic nature of these spikes. Complicating matters further are the contrasting findings from various missions. While NASA Curiosity rover has repeatedly detected methane near the planet's surface, the Trace Gas Orbiter, designed specifically to study Martian gases, has found little to no methane presence from its vantage point in orbit. This inconsistency has only deepened the mystery. If the source of methane on Mars is indeed biological, it could represent one of the most groundbreaking discoveries in the history of space exploration, a sign of life beyond Earth. Even if the methane has a geological origin, understanding its production could still offer valuable insights into the red planet's history and its potential to harbor life. Regardless of its source, the methane mystery continues to fuel debates while inspiring new research and exploration efforts. With missions like the Perseverance rover and future sample return projects, scientists hope to uncover more clues, inching closer to solving this enigma. As we ponder the implications of methane on Mars, we are reminded of how one molecule can open up a world of possibilities. Moving forward, let us explore yet another perplexing phenomenon, this time focused on the planet Saturn and its astonishing hexagonal storm system. As the next phase of our exploration unfolds, let us delve deeper into the competing theories surrounding the mysterious methane on Mars and why this enigmatic finding holds such significance. On one hand, the possibility of life producing methane sparks the most excitement. If microbial life exists below Mars's surface, it could be releasing methane as a metabolic byproduct, similar to some microorganisms found in extreme environments here on Earth. The idea that such life forms could exist in subsurface aquifers shielded from the harsh radiation and freezing temperatures on the Martian surface, keeps this theory alive. On the other hand, the geological explanation offers an equally compelling story. Processes like serpentinization involve chemical reactions between water, carbon dioxide, and certain minerals in Martian rocks to generate methane. This would indicate that Mars has an active subsurface environment, with heat and chemical activity still persisting long after the planet lost its magnetic field and much of its atmosphere. Adding to the intrigue, recent developments have highlighted just how complex the methane mystery really is. The Perseverance rover, equipped with advanced instruments, has been gathering data in areas believed to have once hosted ancient river systems or lakes. These regions are prime candidates for detecting potential biosignatures, including methane. Meanwhile, the Trace Gas Orbiter has been scanning Mars from above, looking for atmospheric patterns that could help pinpoint the origins of methane emissions. Yet, the lack of consistent findings continues to challenge scientists. The methane detected by rovers on the ground sometimes seems absent from orbital measurements, suggesting processes at work that we do not yet fully understand, such as rapid methane breakdown or localized emissions escaping detection at higher altitudes. Understanding the source of Martian methane is crucial not just for the quest to find extraterrestrial life, but also for piecing together the geological and atmospheric history of Mars. Methane could offer clues about the planet's habitability, its water history, and the stability of its environment over billions of years. Whether biological or geological, solving this puzzle would mark a major milestone in planetary science and our understanding of the cosmos. With ongoing missions and future projects on the horizon, humanity edges closer to uncovering the truth behind this perplexing phenomenon. Now, shifting our attention away from Mars, we venture toward Saturn, where its North Pole hides one of the most astonishing and bewildering mysteries in our solar system: the extraordinary hexagon-shaped storm that has left scientists equally fascinated and puzzled. Now turning to Saturn, we encounter one of the most striking phenomena in the solar system, a massive, perfectly geometric hexagon-shaped storm at its North Pole. First observed by the Voyager spacecraft during its flybys in the early 1980s, this bizarre six-sided jet stream immediately captured the attention of scientists and space enthusiasts alike. Spanning nearly 30,000 kilometers in diameter, this storm is so enormous that it could fit 4 Earths inside its boundaries. What truly baffles researchers is the precision of its shape. Unlike the ragged and chaotic appearance typically associated with planetary storms, Saturn's hexagon boasts sharp, well-defined edges that rarely waver. It is as if nature itself attempted to draw a perfect polygon in the planet's turbulent atmosphere. The hexagon's mesmerizing visuals have only added to its intrigue. Images captured by the Cassini spacecraft during its mission from 2004 to 2017 revealed layers of swirling clouds, with some areas exhibiting hues of blue and green, while others transition into golden tones as Saturn's seasons change. This dazzling array of colors is not just a spectacle, but also a clue to the chemical and thermal processes occurring within Saturn's atmosphere. Scientists hypothesize that the hexagon is a result of complex fluid dynamics, a standing wave pattern generated by high-speed winds circling the planet's pole. Laboratory experiments on Earth using rotating fluids have managed to recreate similar geometric shapes, providing some insight into how such a structure might form. However, the extraordinary stability of Saturn's hexagon, persisting for decades without significant alteration, remains an unsolved puzzle. Adding another layer of mystery is the vertical structure of the storm, which extends deep into Saturn's atmosphere, indicating that this phenomenon is not just a surface feature but a complex, multi-layered system. Despite years of observation and modeling, no definitive explanation has yet been found for why this storm takes the shape of a hexagon or how it remains so remarkably stable. Exploring this anomaly not only challenges our understanding of atmospheric physics, but also provides a deeper glimpse into the dynamic and often unpredictable forces at play in the outer planets. As the enigma of Saturn's hexagon continues to captivate scientists, we now move further outward into the cosmos, where we encounter an anomaly that may stretch the boundaries of our observable universe, the curious phenomenon known as the cold spot. As the next challenge unfolds, scientists have been delving deeper into the mystery of Saturn's hexagon by recreating similar phenomena here on Earth. Laboratory experiments using rotating cylinders filled with liquids have remarkably managed to produce polygonal patterns that mimic the hexagon structure. These experiments suggest that the shape forms as a result of fluid dynamics specifically, the interaction between differing wind speeds and directions within Saturn's turbulent atmosphere. By tweaking variables like rotation speed and fluid viscosity, researchers have been able to simulate and study the conditions that might give rise to such a fascinating geometric storm. However, even with these controlled findings, the enduring stability and symmetry of Saturn's hexagon present an enigma far beyond what these Earth-based models can fully explain. One of the most intriguing aspects of this anomaly is how it defies the chaotic nature we typically associate with planetary weather systems. Storms on Earth, for instance, tend to be irregular and short-lived, yet Saturn's hexagon has maintained its precise shape for at least 40 years, possibly much longer. This challenges our understanding of atmospheric physics and raises questions about the unique forces at play on the gas giant. Some scientists propose that the hexagon could be locked in place by deep-seated processes occurring in the planet's interior, connecting atmospheric patterns to dynamics far below the visible cloud tops. Others speculate that the energy driving the hexagon might come from Saturn's internal heat, combined with its rapid rotation, which influences the high-speed jet streams circling the pole. What makes this mystery even more compelling are the breakthroughs we are yet to achieve. Advanced computational models and spacecraft missions continue to refine our understanding, but the complexity of this feature suggests we are only scratching the surface. The hexagon is a powerful reminder of how much we still have to learn about the behavior of atmospheres under extreme conditions. Saturn's hexagon is not just a striking visual phenomenon, but a scientific puzzle that may one day unlock new insights into the workings of our own planet's atmosphere and weather systems. Moving forward into the depths of the cosmos, we encounter another anomaly that has drawn the attention of astronomers for decades. A strange, cold region within the cosmic microwave background that could hold secrets about the origins of the universe. Now turning to the vast expanse of the universe, we come across an anomaly often referred to as the cold spot, a puzzling region within the cosmic microwave background, which is the faint glow left over from the birth of the universe nearly 14 billion years ago. This area is notably cooler than its surroundings, a stark contrast in a sea of otherwise uniform temperature variations. First identified in data collected by the Wilkinson Microwave Anisotropy Probe in 2004, the cold spot has since been confirmed by the Planck satellite, cementing its status as one of the most enigmatic features of the cosmos. What makes it so fascinating is not just its temperature, but also its size, spanning about 1 billion light-years across. It is far larger than typical fluctuations in the cosmic microwave background, which has left scientists searching for explanations. One prevailing hypothesis suggests that the cold spot could be caused by a massive supervoid in this region of space, an area with far fewer galaxies and less matter than usual. Such a void could alter the path of light through a phenomenon known as the integrated Sachs-Wolf effect, where photons lose energy as they travel through an underdense area, leading to a cooler appearance. However, even this explanation falls short of fully accounting for the extent and intensity of the cold spot, leaving room for alternative theories. Some researchers propose it might be evidence of something far more extraordinary, perhaps the imprint of a collision between our universe and another, a tantalizing hint at the existence of a multiverse. If true, the cold spot could represent the first observational clue that our universe is not alone, opening up an entirely new dimension to our understanding of reality. Despite the intrigue, the cold spot remains an open question in modern cosmology. Its peculiar nature has sparked debates and fueled innovative research, with some scientists even questioning whether it could be a statistical fluke, an anomaly that simply challenges the laws of probability. Whatever the case, it serves as a powerful reminder of just how much we have yet to uncover about the origins and structure of the universe. As we delve deeper into the mysteries of the cosmos, anomalies like the cold spot push the boundaries of what we know and compel us to consider possibilities that once seemed unimaginable. And with that, we turn to yet another enigma, one that takes us back to the earliest conditions of the universe itself, the ongoing search to understand the elusive material known as dark matter. As the next phase of the journey unfolds, the idea of the cold spot being linked to a multiverse takes center stage. Imagine for a moment that our universe is just one of many, each separated like bubbles in an endless cosmic foam. The theory suggesting that the cold spot could be a result of a collision between our universe and another opens the door to this extraordinary possibility. Proponents of this hypothesis argue that during the early stages of the universe, such a collision could have left an imprint on the cosmic microwave background, creating the cooler, anomalous region we now observe. If true, this would not only explain the cold spot's peculiar characteristics, but also serve as groundbreaking evidence for the existence of a multiverse, a concept that has long fascinated both scientists and philosophers. The implications of such a discovery would be staggering. It would fundamentally reshape our understanding of reality, suggesting that our universe is not an isolated entity but part of a much larger, possibly infinite system. Each universe within the multiverse could have its own unique physical laws, dimensions, and even forms of life, hinting at realms of existence far beyond anything we can currently comprehend. While this idea may sound like science fiction, it is grounded in serious scientific theories, including string theory, which allows for the existence of multiple dimensions and parallel universes. The cold spot, then, could be the first observational clue pointing us toward this dazzlingly complex and layered reality. However, as captivating as the multiverse hypothesis may be, it is far from universally accepted. Testing this idea presents significant challenges, primarily because any evidence of other universes would be indirect at best, leaving much of it open to interpretation. Critics argue that alternate explanations, such as the presence of a supervoid or statistical anomalies, must first be thoroughly explored and ruled out before jumping to such extraordinary conclusions. Despite this, the mere possibility of the cold spot being linked to a multiverse continues to inspire bold theoretical research and ambitious observational efforts, keeping the debate very much alive. Whether the cold spot ultimately turns out to be the key to unlocking the secrets of the multiverse or simply a quirk of cosmic structure, its mystery serves as a powerful reminder of how much remains to be discovered. Each new insight brings with it more profound questions, challenging the limits of human understanding and pushing the boundaries of what we dare to imagine. With that in mind, we now shift our focus to another of the universe's captivating enigmas, the elusive and invisible substance known as dark matter. Now turning to the next profound mystery, we delve into the enigma of dark matter, an invisible substance that forms the backbone of the universe. Despite being undetectable by any current instruments, dark matter is believed to make up almost 85% of the universe's total mass. Its presence can only be inferred indirectly through the gravitational effects it exerts on visible matter, radiation, and the overall structure of the cosmos. Imagine observing a spiral galaxy, its stars and planets orbiting at incredible speeds. According to our understanding of physics, these outer regions should fly apart unless some unseen mass is holding everything together. That unseen force, scientists believe, is dark matter. One of the most compelling ways scientists detect dark matter's influence is through gravitational lensing. This phenomenon occurs when a massive object, like a galaxy or a cluster of galaxies, bends and magnifies the light from a more distant object behind it. The amount of bending observed cannot be explained solely by the visible mass of the lensing object, hinting at the presence of dark matter as the hidden scaffolding providing extra gravitational pull. Another clue comes from the rotational speeds of galaxies. Observations show that stars at the edges of galaxies move just as fast as those near the center, defying predictions based on the visible mass alone. This consistent yet baffling pattern suggests that dark matter forms an invisible halo around these galaxies, providing the necessary gravitational glue to keep them intact. Yet, for all its apparent influence, dark matter remains frustratingly elusive. It does not emit, absorb, or reflect light, which means traditional telescopes cannot observe it directly. It also interacts weakly, if at all, with regular matter, making it incredibly challenging to study. Researchers have proposed numerous theories about what dark matter might be composed of. Some suggest it could consist of exotic particles yet to be discovered, such as weakly interacting massive particles, while others have speculated about entirely new physics beyond our current understanding. Experiments around the world, from underground detectors to particle accelerators, are ongoing in the quest to capture even the faintest trace of this mysterious substance. Despite decades of rigorous scientific effort, dark matter remains one of the greatest puzzles in modern astrophysics. Its mystery challenges the boundaries of what we know about the universe and highlights the limitations of current technology and theories. What makes it particularly fascinating is how it forces us to confront the vast unknown, pushing scientists to rethink fundamentals and explore new frontiers. As we continue to search for answers, dark matter stands as a humbling reminder of how much of the cosmos is yet to be understood. With this enigma in mind, we now turn to another groundbreaking concept reshaping our understanding of the universe: the force driving its accelerated expansion, known as dark energy. Moving forward, we encounter another profound mystery: dark energy, a force so enigmatic that it challenges the very framework of modern physics. Unlike dark matter, which holds galaxies together, dark energy is believed to be the driving force behind the accelerated expansion of the universe. This astonishing revelation came to light in the late 1990s when two independent teams of astronomers were studying distant supernovae, which are massive explosions marking the deaths of stars. They expected to find that the expansion of the universe was slowing down due to the pull of gravity. Instead, they discovered something entirely unexpected: the expansion was speeding up. This groundbreaking finding not only earned them a Nobel Prize, but also fundamentally changed our understanding of the cosmos. To picture this, imagine throwing a ball into the air. You would naturally expect it to slow down and eventually fall back due to gravity. But what if instead the ball kept accelerating upward faster and faster with every passing moment? That is, in essence, what is happening to the universe. The galaxies are moving away from each other at ever-increasing speeds, and the force causing this acceleration is what scientists call dark energy. What makes dark energy so perplexing is that it appears to make up roughly 68% of the universe, dwarfing both dark matter and visible matter combined. Yet, its nature remains almost entirely unknown. Some theories suggest it could be a property of space itself, tied to what Albert Einstein once called the cosmological constant, a term he introduced and later disregarded, only for it to resurface decades later to explain this phenomenon. Others propose it may be tied to an entirely new form of energy that interacts with space and time in ways we cannot yet comprehend. One of the ways scientists infer the effects of dark energy is through its influence on the large-scale structure of the universe. By observing the cosmic microwave background, essentially the afterglow of the Big Bang, and the distribution of galaxies, they can detect subtle patterns that hint at the presence of this mysterious force. Yet, these observations, while fascinating, offer more questions than answers. Why is the expansion accelerating now instead of earlier in the universe's history? Could dark energy change over time, or is it constant? These are just some of the puzzles that continue to baffle scientists. Dark energy is more than just an abstract concept. It has profound implications for the fate of the universe itself. If this force continues to dominate, it could lead to scenarios as extreme as a big freeze, where galaxies drift so far apart that the universe becomes cold and lifeless, or even a big rip, where the very fabric of space itself is torn apart. Alternatively, if dark energy somehow weakens or changes over time, the universe's future might take an entirely different path. What sets the study of dark energy apart is how it challenges our deepest assumptions about reality. It forces us to question not only our understanding of the universe's origins, but also its ultimate destiny. Like dark matter, it stands as a humbling reminder of the vast unknown, a frontier that inspires both awe and relentless curiosity. With dark energy reshaping our view of the cosmos, we now venture into an even more speculative realm to ponder. Could space itself harbor properties so mysterious that they redefine our understanding of existence? Now turning to the next profound question, we ask, could space itself be an anomaly? At first glance, space might seem like an empty, passive backdrop where celestial events unfold. However, some scientists believe that space could possess its own mysterious properties, or even hidden dimensions that remain beyond the reach of our current understanding. Imagine, for instance, wormholes, hypothetical shortcuts through space and time that could connect distant points in the universe instantly. Though they have yet to be observed, their possibility arises from equations in Albert Einstein's theory of general relativity, tantalizingly suggesting that the fabric of space might be far more dynamic and complex than we assume. Adding to this mystery is the concept of quantum fluctuations. These are tiny, unpredictable changes in energy that occur even in the vacuum of space, seemingly out of nowhere. This phenomenon implies that space is not entirely empty, but rather teeming with spontaneous activity at an unbelievably small scale. Some theories suggest that these fluctuations could even be responsible for the creation of entire universes, hinting at a multiverse where countless realities might exist parallel to our own. Then there are exotic particles like actions or gravitons, theoretical entities that, if proven real, could completely redefine how we view space and its interactions with matter and energy. These particles are believed to exist in conditions beyond what we can currently recreate, making them elusive but potentially revolutionary in our quest to understand the cosmos. What makes these ideas so fascinating is how they challenge the very notion of emptiness. If space itself has structure, properties, or hidden dimensions, it could mean that the universe is not just expanding into nothingness, but interacting with something far more intricate. Could space be harboring secrets that explain dark energy, dark matter, or even the nature of consciousness? The possibilities stretch the boundaries of both science and imagination, leaving us with more questions than answers. As we continue to probe these enigmatic ideas, one thing becomes clear: space is not simply a vast void, but a frontier bursting with potential discoveries. With this dynamic tapestry of theories in mind, we turn our attention to the role of technology in unraveling these cosmic mysteries, and how humanity's ingenuity is paving the way for answers to questions we once thought unanswerable. With the next phase of the journey in sight, we delve into the incredible role technology plays in unraveling the mysteries of space. Advancements in technology have transformed our ability to explore the cosmos, allowing us to see farther, analyze deeper, and hypothesize with greater precision than ever before. Take, for example, modern telescopes like the Hubble Space Telescope or the James Webb Space Telescope. These groundbreaking instruments act as our cosmic eyes, capturing images and data from distant galaxies, stars, and phenomena that were once beyond our reach. The James Webb Space Telescope, in particular, is a marvel of innovation. Equipped with advanced infrared sensors, it can peer through clouds of cosmic dust to reveal the hidden processes of star and planet formation, as well as detect the faintest traces of light from the earliest periods of the universe. Spacecraft, too, have revolutionized our understanding of the universe. Probes like Voyager, New Horizons, and the Parker Solar Probe have ventured into the unknown to collect data directly from locations scientists could only dream of studying a few decades ago. Their findings have not only enriched our knowledge of the outer planets, but also challenged our assumptions about the nature of interstellar space, revealing unexpected phenomena like the density of plasma in the space between stars. These probes extend humanity's reach, bringing back answers to questions we have barely begun to ask. But perhaps the most transformative force in modern science is artificial intelligence. With its ability to process vast amounts of data quickly and accurately, artificial intelligence has become a critical tool in interpreting the immense streams of information generated by our instruments. Artificial intelligence systems are identifying patterns in gravitational waves, mapping the structure of galaxies, and even assisting in the search for habitable exoplanets by analyzing thousands of potential candidates at speeds no human team could match. By automating complex calculations and uncovering subtle correlations, artificial intelligence is not just accelerating discoveries, but also opening doors to entirely new types of cosmic inquiry. Looking ahead, the potential of upcoming missions and technologies is staggering. Projects like the European Space Agency's Laser Interferometer Space Antenna aim to detect gravitational waves directly from space, providing insights into black holes and other massive cosmic events with an unprecedented level of detail. Meanwhile, planned space-based observatories like the Nancy Grace Roman Space Telescope will explore dark energy and dark matter, helping scientists better understand the forces shaping the universe's expansion. Such missions are poised to revolutionize our grasp of the cosmos, pushing the boundaries of what seemed possible just a generation ago. Through these advancements, technology serves as both a lens and a key, illuminating the unknown while unlocking the answers to age-old questions about space and existence itself. And as we embrace this age of discovery, we find ourselves standing on the threshold of a new era, where mysteries once thought unsolvable may soon reveal their secrets. With that in mind, let us reflect on why these cosmic puzzles matter and how they inspire us to keep reaching for the stars. As the sun rises on the next chapter, let us reflect on why space anomalies matter so profoundly to humanity. These unexplained phenomena are far more than just puzzles for scientists to solve. They act as beacons of curiosity, igniting a passion for discovery and a hunger to understand the true nature of the universe. Each anomaly, from the strange dimming of distant stars to the mysterious signals from the depths of space, challenges our knowledge and compels us to ask questions we may never have considered. In doing so, they expand the boundaries of human thought, pushing us to explore realms of science, philosophy, and imagination that redefine what we believe is possible. Moreover, these cosmic mysteries play a pivotal role in advancing our understanding of the universe. The pursuit of answers leads to groundbreaking innovations, not just in astronomy but across all scientific fields. Technologies developed to study anomalies often find applications in everyday life, from medical imaging to communication systems. By stretching the limits of what can be observed, measured, and theorized, these anomalies drive progress, turning the unknown into opportunities for growth and learning. Beyond their scientific importance, space anomalies deeply resonate with people on a personal level. They remind us of how small we are in the grand tapestry of the cosmos, yet highlight the immense potential of human ingenuity and determination. The questions they raise about our origins, our place in the universe, and the possibility of life beyond Earth spark a unique sense of wonder that unites people across cultures, generations, and beliefs. This shared curiosity fuels not only scientific inquiry but also art, literature, and storytelling, providing a timeless source of inspiration that enriches human culture. Ultimately, space anomalies matter because they embody the essence of exploration. They encourage us to look beyond what is immediately known, to embrace uncertainty, and to imagine a future where today's mysteries become tomorrow's discoveries. They are a powerful reminder that the universe is a vast, dynamic, and extraordinary place, filled with secrets waiting to be revealed. And as we continue this journey of discovery, these anomalies will remain a testament to humanity's enduring quest to understand the wonders of existence. As we reach the conclusion of our journey through the top 10 most intriguing and unexplained space anomalies, it is clear that these mysteries serve as a window into the vast, uncharted territories of the cosmos. From enigmatic signals to celestial phenomena defying explanation, each anomaly represents not only a scientific puzzle, but also a reminder of the endless depths of the universe we have yet to understand. They reveal how much is still unknown and how each discovery brings with it a cascade of new questions, fueling humanity's relentless pursuit of knowledge. These phenomena challenge the boundaries of what we know, inspiring both awe and curiosity, and driving scientific innovation that pushes us closer to uncovering the secrets of existence. Through this exploration, we've glimpsed the incredible complexity of our universe and the countless opportunities it offers to learn, discover, and dream. Each anomaly is a frontier waiting to be explored, a testament to the universe's ability to surprise and fascinate us at every turn. As we continue to unlock one mystery, a dozen more await just over the horizon, reminding us that curiosity and wonder are at the heart of human progress. Now, we want to hear from you. Which of these anomalies captivated your imagination the most, and what are your own theories about the mysteries of the cosmos? Share your thoughts in the comments below, and let's continue this conversation about the wonders of space. Don't forget to like this video, subscribe to our channel, and hit the notification bell so you never miss out on our next cosmic exploration. Thank you for joining us on this incredible journey through the unknown, and until next time, keep looking up at the stars and wondering what mysteries they still hold.